Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the quadratic relations part of the course. And in this video, we're going to look at some word problems involving quadratic relations. And here's the first question. It says, a flare is fired upwards from a sinking vessel. The height of the flare in meters is given by this equation. So we'll look at that equation in more detail in just a second. So this is the height of the flare in meters, where t is time measured in seconds since the flare was fired. And then we're going to be doing these three questions, which we'll look at in just a second. So let's look closely at that equation. So again, it's height in meters compared with time of a flare shot from a sinking vessel. So we see that this is a quadratic equation because of t squared. It's in standard form, ax squared plus bx, and plus c, well, we can write plus 0 to represent that c term. And we know, therefore, that it starts at height equals 0. So in other words, the sinking vessel is probably right at the water's edge. So the flare is considered to be at the water's edge or at height equals 0 when this equation begins. What else do we know? Well, it's a negative parabola. So very quickly, like I always recommend you do, visualize either mentally or on paper like I do, what happens in this equation. So starting at 0, a flare is shot into the air, reaches a maximum, and then until we're told differently, we assume that it comes back down to the ground. Okay, so that's what's going to happen. Again, it's time against height, so let's go look at the first question. It says determine the maximum height of the flare and the time required to reach this height. So we need to find the maximum height. So find the maximum height of the flare. Now we know that anytime you're asked to find a maximum or a minimum in a quadratic relation question, that we're really looking for the vertex. So how are we going to find the vertex? Well, let's go grab that equation so we have it in front of us. Doot, doot. And here it is. So here's the equation, and let me just get rid of the stuff behind it so we can see it clearly. So if you had this equation and you were told to find the vertex, what would you do? Well, we have options. There's three ways of finding the vertex. One, you could complete the square. So completing the square is the method that turns a standard form equation, like this one, into a vertex equation, and therefore, obviously, you can find the vertex. Or you can try factoring, and if you can factor, then you can use the factored form to find the roots. And again, when you have the roots, you can find the axis of symmetry and therefore the vertex. Oops, find roots. And if you don't feel like factoring, the other method is you could use the quadratic formula. And just like factoring, the quadratic formula will help you find the roots. And from the roots, you can find the axis of symmetry and the vertex. Any of these are completely fine. I probably wouldn't, well, I might do any of these. I don't know. I'm actually going to factor because we don't get a lot of opportunities to factor in this unit. So I'm going to common factor negative 4.9t from both terms. And again, common factoring is like doing division. So 92 divided by negative 4.9 is what I have to put into that missing spot. So in my calculator. So here I get approximately negative 18.78. And again, you didn't have to factor. You could have used the other methods, but just to review, I need to make sure that if I factored correctly, then this term, negative 4.9t, would multiply into the bracket to give me my original expression. So you can always double check that, but I'm pretty confident that my math is right. So I've now common factored. And now what I want is I want to be able to find the roots. So another name for the roots is the x-intercepts, or in this case, the t-intercepts. And to find t-intercepts, you let the h equal 0. So we're going to let h equal 0 in our factored expression. And then we're going to solve for t. So now we're using the multiplication principle. I have this thing multiplied by a bracket. Well, if this thing was equal to 0, it doesn't matter what the bracket is 0 times anything is 0. So what value of t makes that 0? Divide both sides by negative 4.9, and I have one of my roots. Now, the opposite is also true. If this thing was equal to 0, it doesn't matter what's over here. If this is 0, 0 times anything is 0. So we need to figure out what makes that bracket 0 by doing simple equation solving. So there's my second root. So I have now found the two roots of this particular equation. Now that I have the roots, we go back and think, if you have the roots, and again, little sketch here to remind ourselves, if you have the roots, boom, boom, then the midpoint of the roots gives you the axis of symmetry. So we're now going to take the midpoint of the roots to find the axis of symmetry. So this is an axis of symmetry. So adding the two roots together and dividing by 2 gives us our axis of symmetry value. So the equation of the axis of symmetry is 9.39. So now we know that the midpoint of the roots is 9.39 seconds, and that means that 9.39 seconds after being fired, we hit, or the flare hit that maximum point. So now we just have to figure out, well, where is that maximum? So at t equals 9.39, we now need to find the height. Another way of thinking about that is we now know that the vertex has 9.39 as the first term, and we're looking for the second term. So we're going to take the original equation, height equals negative 4.9 t squared plus, what was it? 92t. And we're going to sub that value of t, the midpoint value from the roots, into the equation. And we're going to solve. And that solution will be the y-coordinate, or in this case, the h-coordinate of the vertex, also known as the maximum. So when I do the math in my calculator, I get an answer of 431.8 meters. And I'm rounding to 1 decimal here. I kept 2 decimals in my question, so my answer will have 1 decimal. So let's make sure we have the answer. A, determine the maximum height of the flare and the time required to reach this height. So we have both answers. Here's the maximum height, and here's the time required. So therefore, the maximum height is, and the time required to get there is right here. So let's go on and look at part B. Part B says determine the time it takes for the flare to return to the water's surface. So again, thinking about this particular scenario, here's the flare. It's fired, reaches a maximum, and come back down to the ground. Now, this value here we know is t equals 0 because that's where it starts, at the water surface. This here is when it returns to the water surface. So really, I'm looking for what time does this happen? And think about the math we just did. We just found the roots of this function. We found 0 and 18.78. So in fact, we already did the math for this question. So based on the work from part A, we know that it took 18.78, or let's say 18.8 seconds, to go all the way up and come back down. So we already did that. Let's look at question C. Question C says, for how many seconds is the flare higher than 50 meters? So let's think about the scenario. So we know this is at 0. Here's the flare. We know that this is at 18.8. We know that the midpoint is at 9.4 and the maximum height is at 431.8 meters. Now, what we need to find is for how long is the flare higher than 50 meters? So somewhere around here, the flare gets to 50 meters. So what time does that happen at? I don't know. Let's call that time 1. So at 0 seconds, we launch the flare. A little while later, time 1, it gets to 50 meters. And then all of this time here, it's above 50 meters. But then on the way back down, it gets to 50 meters again and then goes lower. So we need to know, when is it at 50 meters to start with, and when is it at 50 meters to end with? So I need to find both of those answers. So And what this is saying is let height be 50 meters. And now, once you know that height is 50 meters, find time. And hopefully we'll be able to find two values for time. Time 1 when it reaches 50 meters on the way up, and time 2 when it reaches 50 meters on the way down. So let's go ahead and remind ourselves the original equation, height equals negative 4.9 t squared plus 92t. And now in this question, we need to let h equal 50. And now we need to solve for t. So as soon as I let h equal 50, nothing else matters but completing this algebra portion. So I have a quadratic equation and I want to solve, but I can't do any method of solving unless it equals 0. So the first thing is to subtract 50 from both sides so that you have an equation equal to 0. So there we go. And now I have a quadratic relation in standard form. So here's A, B, and C. So let's use the quadratic equation and solve. So let me grab my extra special quadratic equation. Woohoo! So I have all these blanks ready to go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So take out your calculator. Oops, make sure that's a decimal. Take out your calculator. Let's do the math here. X is negative 92 plus or minus. Let's figure out what that discriminant value should be. So 92 squared minus bracket 4 times negative 4.9 times negative 50, close bracket. So I get a value of 7484 under the square root sign. So let's take the square root of that number and we'll split the question into two answers. You'll notice, by the way, I wrote x. That's just the way my brain always works. So let's change to t. So what do we have? We have negative 92 plus, well, what is the square root of that number I found? 86.5 divided by negative 9.8. Or I have t equals negative 92 minus 86.5 divided by negative 9.8. So over here, let's do that math. Negative 92 plus 86.5 divided by 9.8 negative. So here I get an answer of 0.53. And over here, doing this math, I hope you're doing it along with me and not just, passively letting me do math. I get an answer of 18.21. So if we think about what we were talking about before, so this is at about 0.5 seconds. That makes sense. And this is about at 18.2 seconds. So certainly I'm glad that I have two positive answers. And they're between 0 and 18.8 because that makes sense. So what do we know? So according to my math, the ball reaches 50 meters in the air at this time. It continues to be above 50 meters in the air until falling down at 18.2 seconds, it falls down below that height. So for how many seconds is it higher? So we just have to take our numbers and tell you what duration that is. So 18.21 minus 0.53 tells us that for a total of 17.7 seconds, the flare was higher than 50 meters. So a good duration of the time, and that's probably important for people to see the flare and save the sinking vessel. Okay, so hopefully that all made sense, and thus endeth the video.